here's my plan for today and tomorrow. Tomorrow, obviously, we start with this. Then I'm gonna have some group work related to all the stuff from chapter 3 we've done so far and today. And then we're gonna do some graphing calculator work. Because there will be problems in the textbook that require you to use a graphing calculator. Okay. So if you don't have a graphing calculator, I will bring with me my little cooler of calculators. There's not an infinite number of calculators in that cooler. That would be neat. So I only have so many. So if you don't have one and you can get one, get it. All right. So yesterday we talked about the basics of function notation. Like I have this. That's neat. So if I'm given this function, and I'm gonna give us another function. Just because. 2 minus square root of x. I love it. So the reason, one of the most basic reasons we developed function notation is just so I know what the hell function I'm talking about. If I just put a y here and a y there, and I said, what's y when x is 7? You're like, you gave me 2 freaking equations, right? Also, I wanted a quicker way to ask the question, what's the output when the input is, So if I write something like this, g of 4, this tells me a lot. This says, what is the output of the g function when the input is 4? That's what that says. But that's a much quicker way to say that. So math people, you can either call us lazy or frugal with our time. We like to get to the point. We don't want to, this and that, right? So we do a lot of shorthand. Okay. So pretty cool with that. That's what that means. So all that really means then is it's just substitution problems. And substitution problems kick ass. Why does this suck? Because I don't know what x is. Well, now I do. So how would I do this? Yeah, just plug that in, because g of stuff is 2 minus square root of stuff. G of 4 is 2 minus square root of 4. And of course, square root of 4 is 2, so you get 0. 0, sweet. Now, can somebody tell me, let's connect this to the graph. Can somebody tell me what point we know the g function's graph goes through?
0.
Try again?
4, 0.
Yes, cool. Do you see the problem? So the input comes first, the output comes second, x comma y. So in general, whatever letters are in your function, because we know there could be different letters than x and y, the point is always in alphabetical order unless they say otherwise. Does that make sense? Okay. So we normally use x, y, and sure enough, it's in alphabetical order, x comma y. So here, you guys help me out with, we'll do the one I just said a minute ago. It's f of 7. Don't say anything, just do it real quick. All right, what do you guys get?
7.
All right, so let's see, 7 squared, right? Minus 7 over 7. So everything's coming up 7s. 7 squared is
49.
49. Minus 1.
48.
48. So again, what's a point that f goes through?
148.
7.
748.
Yeah, you're good.
I'm done.
Sweet. Is this pretty cool? I mean, I know some people still have trouble with function notation, but that is all it is. It's just a quick way to ask, what do you get when you plug this in? We just want a symbol that says that, and then we just have to do it. So once we know this is asking me, what do I get out of g when I put a 4 in? Well, I just put a 4 in to see what the answer is. Okay, maybe. Okay. Now, so that's function notation. We did talk a little bit about domain and range, if I remember correctly, maybe not. See if I remember. No? Okay, so let's talk about a couple of things. Let's go a step back. So I wanted to start with this, because this is the computational piece, and this might be the part that people remember better. Let's go back and actually talk about the definition of a function. And I think that's what I did. I talked about the definition of a function. Anybody remember the definition of a function? Holy crap. What's that? It is a relationship, it is, but it's a specific kind.
The relationship between two variables, x and y, where for every input x, there can be only the
Okay, all right. Where for every x, for every input, oh Jeff, I always forget the x, there can be only one output. One. Okay, so for example, we saw a few quick examples. If I have a problem like this, domain range, the domain, so I might as well say this. The domain, let's further define this. Domain is the set of all x's that have outputs. So this is the set of all numbers I'm allowed to plug in. Set of all numbers I'm allowed to use, right? So for example, if I had f of x is the square root of x. And I'm always talking about real numbers unless the problem states otherwise. So if I'm talking about real numbers, am I allowed to use any x I want to?
Yep.
I only want real answers. So what's the square root of -1?
I.
Is that real?
No.
No. So if I want real answers, am I allowed to use any input that I want? No. What inputs can I use? What's the lowest number I can put in there? What's the lowest number I can take the square root of and it comes out real? 0. What's the square root of 0? Why? Because 0 times 0 is 0, right? You guys with me still? Okay, so it's the problems we have will always be about real numbers unless they state otherwise. Okay, I love it. So in this case, the domain would be 0 to infinity. Because those are the things I'm allowed to use for x. I like it. The range, what's the range? Anybody? Yeah, the set of all y's that come from the inputs. I always forget that n. That's amazing. Okay. Outputs. It's a new product from that. Does anyone, can you guys think, what's the lowest output that I could get from this? So what's the range? What's the smallest number that can come out of a square root? 0. And then it just grows from there. You guys with me? So the range is actually the same as the domain here, just because that's the way the function works. Okay, I like it. Does this sound familiar? You talked about domain range before, yes? No? Function, okay. So let me do this. We got all this here? So domain is basically all the x's that work, and then range is all the y's that come out. Okay. So, is this a function here? What the hell does that mean, by the way? Input of 1 has an output of what? 3. So this is a weird ass way to define a function, but it is a function because it's a relationship between two variables, right? Here's the one variable is the domain stuff. It could be 1, 2, or 7. That's a variable. And the output variable is 3, and that's the values of the output variable of 3 and 2. Is this a function?
No.
What does it take to be a function? Every input can only have one output. If you say it's not a function, which input goes to more than one output?
7 and 1.
Which input?
7.
7 and 1.
I love you guys. What does 7 go to?
3.
Does it go to more than one thing? Nope.
Oh,
1.
Does 2 go to more than one thing?
no.
Does 1 go to more than one thing? What does 1 go to?
3.
What's the other thing it goes to? Nothing. So does every input have only one output? You could do it. Is there any input that goes to more than one thing?
No.
Nope. So this is a function. Check. Right? So remember I talked about like a function has to make physical sense. I'm pretty sure I did that. Did I throw the... So if I throw the marker and I ask where is it 2 seconds later, you can't say it's 5 feet up in the air and it's 1 foot up in the air. What the hell kind of marker is that? Right, so it's got to make physical sense. So if at 1 second I'm 3 feet up, at 2 seconds I'm 2 feet up, so and then at 7 seconds I'm back up, okay, that's fine. I'm like walking on ground that's like this maybe, right? Are you guys kind of with me? That makes physical sense. Now, what about this one? Obviously the answer is going to be no, right? You already know the answer is going to be no. But can somebody tell me, what would I do to make the answer no? What would I have to have happen?
1 go to 2.
Yeah, something like this. So why is that not a function? Because which input has a problem to be?
1.
Yeah, 1. So at 1 second, I can't be 3 feet up and 2 feet up. What has happened to me? Something's wrong, right? Okay, the magic trick went wrong, cut in half. Jeff's up here and down there, it's not good. You guys with me? Okay. Okay. So let's do this. This is not a function. Not a function because at least one input has more than one output. No good. Okay. I'll lock it. So, what about, let's see. Yeah, okay, let's do that. I don't know if I did this yet, you guys. I want to be a little specific here. Let's see. Sure. Shit. Okay. Noises unless you want to. Couple things I want to ask you. First off, do you guys remember how to tell if a graph is a function? What test do we use? Vertical line test, which is just when I draw a vertical line, that is this x. If every vertical line hits the thing only once, that means that each x has only one output. If I had a graph that did that, this x, for example, has multiple outputs. So that's why a vertical line test is just the function definition, visually. So this is obviously a function. So 1 function, yes. 2, what's the domain of this function? So what's the domain relate to? Which variable? X, or the input, but generally x. So what x's am I allowed to use, or what x's have outputs? What's the smallest x that has an output?
-3.
-3. Up to, and it's connected, so it includes every point, every number in the middle. Every one of these numbers has an output. So the last thing that has an output is,
+4.
yeah, it looks like it wants to be 4. It's a little crooked because I'm right here. So you gotta give me a little board license. 4, I include. What would I have to make this if I wanted to make this a parenthesis?
No.
I'd have to make this, but if that was an open circle, then I would not include 4, right? For example. Is that cool? Because Does 4 have an output now if I change that to an open circle? No. So can 4 be a part of the domain? No. You have to now have an output to get into this globe. So what about the range? So now I kind of look along the y-axis. If I'm walking along on the y-axis, what's the first time, now this might get a little weird, what's the first time I see an output? I mean, sorry, an input. Yeah, -3, but now that I made that an open circle, right? Is that cool? Don't include -3, but that's kind of like where it starts. And then what's the highest value I see an input for? An output for? 2. So x's tell me the domain, y's tell me the range. Do I include 2?
Yeah.
Yes, because it's a closed circle. Kick ass, yes.
We were taught like in high school that like the greater sign, less sign, domain and range.
Okay.
I don't know like if it's like still the same if we were to write it like that.
Nope. So specifically, a lot of problems are going to ask for interval notation. Write your answer in intervals. These are intervals. But just so you know, how would you write this? How would you have written this in high school? You would have been -3. Am I including -3? Yes. So that would be less than or equal to x. And I'm not including 4. So this inequality means the same thing as this interval. I like it. But if I ask for interval notation and you give me this, that's not interval notation. Okay, I like it. Maybe. Not too bad, right? Not too rough. Okay. So you can be given domain and range questions in function form. You can be given domain range questions in graph form. You can be given them in the DR form, all these different forms. They all have the same question. Oh, I'm sorry, what's up? Oh, yeah, sure. Okay, let me do another one real quick just to answer that. Let's see. Okay. Everybody got this business? Okay. Yeah, all right, that's not a bad point. Real quick, I'm just gonna make a real quick, rough little. So if I had something like this. Okay. Let's just talk about the domain for this question. Why is the domain a little bit freaky here? Because I can't go from the smallest to the largest, because what's kind of happening in the middle? Is there an output for 1/2? So what's the lowest thing that has an output? -2 has an output. And then where do I have to stop? Careful, that's the output.
0.
That's 0. 0. So all of these have outputs. 0 has an output, but then, oh shit. So I got to stop at 0. And of course, like you said, I'm going to start over again, aren't I? I'm going to start up again. So I'm going to union this onto it. And of course, what? No, careful.
Or positive 1, sorry.
1 has an output. The 2, yeah. And that's where it stops here. Domain always x's. Range always y's. So thank you, that's a good question, because that's going to show up again, like we saw with inequality, solving inequality, absolute value inequalities. Little union dude showed up. Okay. If I remember correctly, hopefully you finished that. All right, how are we doing so far? Is that all right? Yes?
For the first one, isn't the domain -2 and 2?
Say again, sorry?
Like the domain for the first one is -2 and 2, or it's
All right,
-2?
careful. Domain relates to what variable? X's. 2 is a y. So you always look along the x-axis. Along the x-axis, -2 has an output. All these have outputs, right? Up to what input? 0 has an output. Domain is about the x values that have outputs. If you said -2 to 2, that's a y, that's an output. That shouldn't show up in the domain. Does that make sense? So
Yeah.
Domain is specifically the x values that go somewhere. And that's why we have to leave this out, because these x values go nowhere. Is that all right? Okay, maybe? Okay. And just in case, just to do one more freaky example, if you happen to see this, I can't remember, this is in the homework. If you happen to see this, okay, so that's my, here's my function, this is my function. What's the domain? Is it gonna be an interval of numbers? Isn't it a finite thing? Isn't there, how many x values actually work? 3 of them. So you're gonna list them. So you're gonna put them in set notation. Interval notation automatically means include everything between this and this. But here I only want to include what? What x values?
Negative.
Negative 2 goes somewhere. What other x value goes somewhere?
Negative.
Negative 1 goes somewhere.
And 2.
And 2. What would the range be? Make yours better than that. Oh my gosh. Okay, sure. 0, 1, 2. So these are all the inputs that have these numbers as outputs. Kick ass. Okay. So that's like the ultimate. You don't need interval notation because interval notation is what I use when I have everything between things. Here it's just discrete points. Okay. Okay. All right. So. A little bit of time I have left. The last couple things I want to talk about are piecewise functions. We saw those. I think I looked at one of those at least yesterday, if I remember correctly, maybe not. And I want to kind of talk about composition of functions. So I'm going to do a little bit out of order from the book. So let me first, let's do this. How would you graph this? Let's start here. This is just a basic function. What's a good thing to know to be able to graph this? If you don't know what something looks like, what are you going to create to be able to make points to graph it? A table, XY table. A really good thing to know is what am I allowed to put into it? So really, anything? You sure? One won't work, will it? Does 1 work?
No.
Shit. So, real quick, I really want this to make all the sense in the world. How am I going to figure out the domain of this? Well, tell me this. Because we don't want to graph. Do you want to graph complex numbers? Do you want to graph like the thing on the video when he picked it up and there's all those colors? Maybe not, right? So, what can happen? What kind of number can I put in here? What kind of number could this be for it to work? No, don't give me a specific number. What kind of number does it have to be? What kind of number works inside of a square root? What kind of number can I put right here for it to work? Okay, positive or 0. So the inside, whatever the hell the inside is, it will work if it's positive or 0. What does positive mean mathematically? For something to be positive, it has to be greater than 0. Good. So the inside, so I just say in English, what has to happen to make this function happy? The inside has to be at least 0. Is that cool? Yes?
But not 1, right?
No. Don't think I had too much. The inside, whatever the hell the inside is, has to be at least 0.
Like together, okay.
Yes. Don't try to do everything at once. Now you take, what is the inside in mathish? What's the inside? What's inside? What is it?
X squared.
Yes, x minus 2 has to be at least, how do you write at least in mathish? Greater than or? Equal to. 0. Now, how do you solve that?
Plug in a number.
Don't plug numbers in. Yeah. Add 2. Yeah. Does that say it can't be 1? Yes. Right? 1 doesn't work, so if we do this work, we better not include 1. 2 works, because when I put a 2 in, what do I get?
1.
Zero.
Or 0.
0. 3 works, right? Okay, so now I know, since I did this work, I know how to make my XY table. What's the very first number I can use?
0.
2. Oh, you guys so much. We just figured this out. So what x's am I allowed to use? They have to be at least 2. So I'll start with 2. When I plug a 2 in, I get 0. When I plug a 3 in, I get, say again? 1. Do I want to plug 4 in?
Yeah.
I don't. What does 4 come out to be? Rad 2. Can you graph that easily? No. What's the next? Can you guys figure out what's the next smart thing to put in here so I end up with a nice square rootable number? 6. If I put a 6 in, what do I end up in here? 4. Square root of 4 is? 2. So that's the next thing to understand. When you have an XY table and you're creating it, you can pick nice frickin' things. You don't have to pick every number and go insane trying to graph 1.414. Yes?
The y, the 3 would be valid one.
Say again? Sorry? Yeah, what's the square root of 1?
Oh, yeah.
Okay, you're good. You're good. You're right. It's square root of 1, yeah. Okay, maybe. All right. Does anyone know what a square root function basically looks like? This is the next thing. The more you know already what it's supposed to kind of look like, the more you don't need as many points. Anybody know what they look like?
My graph.
Yeah, what would the graph, like a parabola looks like squared looks like this, yes? Can anyone do this in the air for a square root? Whoa. Whoa. All right. Like that neat stuff. You guys are doing trig before we're doing trig. So square root just look like that. Yeah. So it looks like a parabola. Now watch this, it's cool. X squared and square root. Aren't they connected? Aren't they like opposites? So here's x squared. The square root basically is this thing falls over and this falls off. So here's a squared. Yeah. A square root is basically this falls over and the bottom part falls off. So this is, square root just looks like the upper part of that after it fell over. And we're going to talk about inverse functions later in this chapter, right? I don't know if you guys remember inverse functions. They're symmetric in a certain way. Okay, but we'll get there. So when I graph this, so let's graph this. So I need to go up to 6 on my x. I need to go up 1, 2, 3, that's fine. Okay. And by the way, I haven't said this yet, and I hesitated to say this, but I'm just going to tell you. The one key job of 176 is obviously to get you ready for calculus. One key thing you need to be able to do in calculus is make accurate but rough sketches. So what is pre-calc going to do? It is going to put you through what I call graphing hell. Right? And I don't say that to make you worried, but I say that to make you realize when you make graphs, if you turn this in, that's shit. There's no scale, there's nothing. There's no scale at all, right? So when you turn stuff in, when it says create the graph, they better show me scale, you better show me some work. So here, I've got the scale set up, 2, 0, kabam, 3, 1, kabam, 6, 2, kabam, and now you can see it's doing that curve, dude. And you can imagine the other half would be here, but why is this half missing? Because the square root cannot come out negative. This is why the bottom fell off. Ah. Okay, maybe. How you guys doing? All right? Anything? Okay. Maybe. So that's the basics of how to graph functions. It really is, you can just make XY tables. If it's a line, you can just do slope y-intercept. You don't need a table, right? Yes? You guys? Okay. Yes?
If there's a +3 at the end, do you start with it?
Say again, sorry.
If there's a +3 at the end,
Oh,
do you
okay.
start?
We are going to get to the point. No, notice, I'm glad you said that. We are going to get to something called transformations, which doesn't mean we're going to go on some life journey. Don't worry. A transformation math-wise, right? And basically, watch this. A square root of x. A square root of x would start at 0. Is that cool? 0, 0, square root of 1 is 1. I'm just gonna do this real quick. Square root of 4 is 2, is that cool? Yeah. How does this relate to this? Poor little arrow.
It's the same shape.
Same exact shape, except that took this and moved it where? Up 2, right? Like over 2, to the right 2. You with me? Not up, sorry. Over 2. So I think that's what you're asking, because if I put a plus 3 on the end, all that would do is to lift this up 3. So we're going to get to the point where we don't need to make a table. I just graph this, and then I move it around. So let me see if I can, let me see. This is a little early for this. Let me see. So how would I, if I had this function, square root of x minus 1 plus 1. Here's the square root of x, right? I know it's really horrible, Jeff. I can't stand it. Hold on. It's really terrible. Okay. Poor little dude. Thank you, Kirby. Okay. Now this is, all right. Think about this. Can you guys see what the smallest number is that I can put in here now? What's the smallest x I could put in here? 1. So basically, when I see x minus 1, it's actually going to shift it up 1. Now, I really want this to make all the sense in the world. If I put a number in here, what's the very first thing I would do to it? If I put 5 in here, what's the very first thing you would do to it? Subtract 1. So every time I put a number in, it's going to be 1 less than that. So I have to put 1 more to make it come out the same. So if I wanted, up here, if I want the output to be 2, I put a 4 in, yes? Down here, if I want this to be 2, I have to put a 5 in. Everything has to be 1 bigger, because the first damn thing I do is take 1 away from the poor little dude. So when I say minus 1, it actually goes up 1. So every point would move over 1. And this would make every point, every output, move up 1. So this would go here, this would go here, and this would go here. So now the new picture looks like that. Now let's check it. What point is this? Let me see if I can make this a little clearer. What's going on? What point is that trying to be there? 5, 3. Jeff, holy crap, dude. There's a parenthesis. Okay. What do I get here when I put a 5 in? 5 minus 1 is 4. Square root of 4 is
2.
plus 1 is 3.
Right.
Yes?
Yeah.
And we didn't make a table of values. We just started with a basic and then moved it. How do you check it? Well, if that point's on the graph, it better work in the function. So that was a little preview. We're not supposed to be starting transformations yet, but I love the question. That's going to be a quicker way to graph some things instead of making the whole table. Okay. All right. So let's come back to this. Put you over there. Get over there. So, let's talk about a slightly funkier function. Piecewise function. Has anybody ever heard of piecewise functions? Not pennywise function, they'll all float down here, but have you heard of it? Do you remember what it sort of looks like?
Yeah, they're functions that change based on the input range.
I love it. And I mentioned this last time, remember the rocket? I shoot a rocket up. Isn't there a function that would tell me the shape of its trajectory, right? So maybe it's on a parabolic arch, you with me? And then it hits something, bam! And now isn't it on a totally different equation? Maybe now it's going in a straight line somewhere, right? So that's why piecewise functions have to exist, because they have to be able to model what could happen in real life. So maybe I have a function that looks like a, holy shit and a half, Jeff. A function that looks like a parabola, if x is, let's say, between 0 and 2. So it's going like a parabola between x equals 0 and x equals, so it's going on a curve, and then we hit something. Ah, shit. And then we look like, let me make this actually, let me make this one more physical. And then so we're going to do, okay. Yeah. So what this says, if x is time between 0 and 2 seconds, I'm going on a nice arch like this, I'm going up to space or something, whee, and then the aliens come in and say, no human, yeah! And now we're going, can you guys see? This is what kind of thing, of course, graphically? What would this would be a parabola. What would this be? If I graph a straight line, is it got a positive or negative slope? Careful. Which one is m? Negative 1. So it's got a negative slope, right? So we're going up to space, the aliens come in here and go, no human, and then push us back down, right? Love you guys. Now you're out there going, this guy believes in aliens. Who knows? So how the hell do I graph this shit? That's a good question. First off, let me ask you this. Can somebody tell me what f of 1 is? Yeah, which piece, yeah, I heard it. Which piece works right now? This one or this one for an input of 1?
That's all.
Yeah, for an input of 1, that's the function, so the output's 1. All right, what's f of 3?
3.
Why?
Use the bottom one.
Why is it not 9? Isn't 3 squared 9?
No.
But the input is 3, that's greater than 2, so I have to use this one. That's the basic idea of how this works. So after 1 second, I'm still in my parabolic arch, right? After 3 seconds, I've already been hit, and I'm coming back down. Maybe? So, to graph this, I make XY tables. I do 2. I do 1 for x between 0 and 2, and I do 1 for x greater than 2. Kind of makes sense. So if I put a 0 in, what do I get? So between 0 and 2, what works? What's the function between 0 and 2?
X squared.
X squared. So when I put a 0 in, I get 0. When I put a 1 in, I get 1. When I put a 2 in, I get 4. On this next one, am I allowed to put 2 in? No, right? So if I just graph this one by itself, what would have to be at 2? What would I have to graph? I'm not allowed to put a 2 in, but what would have to be at 2? Open circle. How do you know where to put the open circle?
You calculate Q.
You have to know what the output would be if you could use 2. That almost sounds like how much wood would a woodchuck chuck? So what I normally do is I'm going to put 2 in, but I'm going to put it in parentheses to remind myself I'm not really allowed to do this. I just need to know where the open circle is going to go. Does that make sense? So if I did put a 2 in, what would this want to be? 4. And then I can use 3, fine, right? 3 is greater than 2. That's the 3 we got. And 4, of course, would be we'll put a 4 in.
Not 2.
2. You guys with me? So it's if I have a function that has many pieces, each one is a function, I should expect to make multiple tables for each piece. So when I graph this, I'm not going to graph a complete parabola because it only exists between 0 and 2. That's a big mistake people make, is they just make the whole parabola. No. It only exists between 0 and 2. It only exists. I don't know what's going on. All right. So let's see. I shouldn't do all that at the back. So here's 0, 1, 2, 3, 4. Yeah, okay. Once my outputs look like they go up to 4, 1, 2, 3, 4. Okay. So see what I just did? I made my scale based on what my inputs and outputs were, so it just came out to be a nice normal one. If my outputs were like 40, 30, 20, I would want the scale to maybe go by 10s, right? Okay. So you can make your own scale. Just has to be consistent on each axis. So let's see, 0, 0, 1, 1, 2, 4. Then the aliens come in. Right, here they are. Here's the aliens. They shoot. I'm going to start to fall down, right? So where does this guy's open circle go? 2, 4. But in this case, that's already there. So there would be an open circle there, but the other side filled it in. Does that make sense? I really want to. If I would have put the 7, if I would have made this 7 minus 2 is 5, there would have been an open circle at 5. But then it wouldn't have made physical sense. 3, 3, 4, 2. So from 0 to 2, it's a parabola, so you better make that curve, right? And then after that, it's just a straight line, right? And this keeps going, because it's greater than 2, so it just keeps going. Yes?
Why do you have to graph x2 if it doesn't work? Like, I don't get why it's there in the first
So
place.
you agree with me, this is why I try to take us down the road I did. You agree with me that there has to be an open circle for the input of 2.
Yeah, because it's not there.
I need to know where to put that open circle.
Okay.
I can't just put it wherever. So I need to know where it would want to be so I can put the open circle there. So that's why I always do this one if there's a number that's not included, because I need to know where to put that open circle.
Okay.
Does that make sense?
I
It's a
think so.
weird thing.
Yeah, I think so.
That's why I put in parentheses saying, I'm not really allowed to do this, I just want to know where the open circle is. Okay. All right, maybe. Have you guys seen piecewise functions? I know you have. Anybody else ever seen that before? A few of you guys? Okay. Do you not like them? Are they a little better now? I don't know. They really aren't that terrible. No? Shit. I'm sorry. I suck. All right. Okay. Do you see how this makes physical sense? I can totally have this, and then I get hit, and I start going that way. And then we're gonna hit the ground at some point. It's gonna suck for us, but oh well, things happen. All right, so those are piecewise functions. Oh, look at me using up all the time. One last thing, and then I'll let you out of here. This is actually section 3.4, I believe. We're gonna come back and do 3.3 tomorrow. And by the way, the test is on the 7th, which is next Wednesday, correct? Tomorrow's Thursday. Tuesday's gonna be review day. So tomorrow I'm gonna have a practice test that I'm gonna give you. On Tuesday, I'll have the answer key. So Tuesday's just review. We're probably not gonna finish all of 3, so the next test is gonna go as far up in 3 as we get tomorrow. Does it make sense? So I'll be very clear on what the test is gonna cover. But let me ask you this. Let me see if you guys can just get this directly. This isn't that crazy of an idea. So if I say f of x is x squared minus 1, and g of x is, Jeff, say 4x plus 5. Sure, let's make it nothing too crazy. Okay. What do you think this wants from us? G of f of 2. What the shit, Jeff? What the shit?
You plug both of them in?
Don't you, plug in the 2 for f of x is?
Yeah, what do you always do in a problem when there's parentheses? Don't you start inside the parentheses?
Yeah.
So this would have been easier if I would have said, what's g of 2, yes? If I would have just said, what's g of 2, what would you have done? Plug a 2 into g. What am I putting into g? Something I don't know yet. So I need to figure out what f of 2 is so I can put it into g, yes? So how do I figure out what f of 2 is?
Plug the 2 into.
Yeah, so what would I put here? Plug a 2 in, what do I?
Like 2 squared.
2 squared minus 1, yes? That's what f of 2 is. Is that cool? So I'm starting in the innermost piece like we almost always do. I need to know what this is so then I can plug it into g. Okay, let me figure out what this is. So that, of course, is 3. And now I can do g of 3.
12 plus.
Yeah. 12 plus 5, 17. So this is called composition, function composition of functions. So it's a function composed of another function. You just work from the inside out like we almost always do. Is that all right? No? Screw that shit? Okay. All right, I mean, that's a quick little thing. I just wanted to throw that out there. There's a little bit more to this, but it doesn't get much harder than this, which is nice. That's why I wanted to do 3-4 first, because it just comes right off of just normal function notation anyway. So that's plenty for today. So tomorrow I'll have the quizzes graded. We got the other quiz on chapter 2. I'll have the practice test. It's crazy. Say again?
How many questions are on the quiz?
On this one?
Yeah, tomorrow.
Oh, I don't know. Normally between 5 and 10.
Okay.
Yeah. So today there was 8 questions. Yeah.
Thank you.
Sure.